Hello everyone, I'm Yunkai, a PhD student at Nankai University. I'm going to give you a presentation on Pass2Edit, a multi-step generative model for getting edited passwords. This is a joint work of our collaboration with Peking University, Xidian University, and the University of New South Wales. Text passwords are typically in the form of alphanumeric or special character combinations. Text passwords are the most prevalent method of user authentication. While many other authentication technologies have been proposed to replace passwords, they have fundamental flaws. For example, although biometric authentication technology has high usability, it has high deployment costs and lacks renewable characteristics. Overall, passwords will remain their status as the most widely used authentication method in the foreseeable future due to its simplicity to use, easiness to change, and low cost to deploy. However, the number of accounts a user needs to manage is constantly increasing, and typical internet users are reported to have 100 passwords. Attackers who compromise one site can gain access to other services protected by the same password. Data breaches often involve stolen passwords. Additionally, attackers exploit users' tendencies to slightly modify existing passwords, making password reuse attacks more realistic. Now, let's explore existing research on password reuse attacks. We highlight 3 main studies based on different technical approaches. Each study has its limitations. For example, the inherent flaws of PCFG limit the performance of Wang et al.'s algorithm, and it fails to leverage large-scale datasets. To address these issues, Pell et al. Introduced the deep learning techniques and trained a sequence-to-sequence model to predict modifications needed to transform passwords. Although this model achieved state-of-the-art success rates, it still has room for improvement. Let's dive into the limitations of pass-to-pass and how our work addresses them. To begin with, I will briefly introduce Pell et al.'s work, namely pass-to-pass. Specifically, it defines 3 character-level automatic modifications: insertion, deletion, and substitution. During training, the model takes the user's old passwords as input and generates a sequence of modifications to transform it into the new password. Here, we give a toy example. We can see that 3 automatic operations need to be performed. That is, delete the character at the 5th position, delete the character at the 6th position, and insert an exclamation point at the 7th position. The first issue is that pass-to-pass cannot capture the mutual influence between password edit operations and the corresponding transform effects. For example, if the PW1 is WANG123 and the PW2 is WANG1 exclamation point, then the modification path consists of 3 automatic operations. Note that after the edit operation del5 has been performed, the original password WANG123 has already been modified to WANG13, and similar situations occur in subsequent editing operations, but pass-to-pass cannot capture such critical changes. Thus, we should establish a direct connection between the edit operations and the corresponding edit effects. Another issue with pass-to-pass is its use of edit distance to filter similar password pairs during model training. This approach may not be accurate. For example, in this table, all 4 password pairs edit distance are 6, but only the first 2 are typical reused pairs. Moreover, in practical attack scenarios, we should also consider users' vulnerable behavior of choosing popular passwords when creating new passwords. To address inaccurate filtering, we introduced the 2-gram cuisine similarity metric. By passing password pairs into 2-gram strings and calculating cuisine similarity based on their frequencies, we can accurately distinguish between different pairs. Empirically, we choose a 0.3 threshold for 2-gram cuisine similarity. Other thresholds can be chosen based on specific circumstances. Now let's introduce our Pass2Edit model. It incorporates a multi-step decision-making mechanism. Similar to Pass2Pass, we consider password modification as a series of automatic edit operations. However, we model password reuse as a multi-step classification problem. At each training step, Pass2Edit takes the original password and the current modified password as inputs, predicting a single-step modification operation. This operation is then applied to the original password to obtain the current modified password. This process is repeated until the modification is complete. In this way, Pass2Edit establishes a direct connection between edit operations and their effects. The neural network architecture of Pass2Edit consists of 3 GRU layers and 2 fully connected layers, making it a classifier rather than a sequence-to-sequence model. To generate edited passwords, we use the beam search algorithm. We input the original password into the neural network to obtain the probability distribution of the first step modification. The algorithm selects the top key valid transformations based on the probability and applies them to the original password. This process is repeated, and the passes are summarized using dotted arrows, resulting in the final password guess set. In reality, users may not only reuse passwords, but also choose popular passwords for their new accounts. To incorporate popular passwords into our model, we mix globally popular passwords. We multiply the probability of each password out by the beam search by a factor alpha. It represents the fraction of users who do not choose popular passwords. We choose alpha as 0.3 based on our data size. We estimate the probability of the popular password based on their frequencies. Finally, we merge the two sets in descending order of probability to form the final guess set. Next, we conduct a comparative evaluation of Pass2Edit against its counterparts, namely Pass2Pass and Target2. We address 3 key research questions. First, how well does Pass2Edit perform? Second, how effective is Pass2Edit in practical attack scenarios? Third, does Pass2Edit's efficiency meet the needs of a real attacker? To answer these questions, we designed 12 practical attack scenarios, including English and Chinese styles, with the password pairs obtained by matching email addresses. The experimental results demonstrate that Pass2Edit outperforms existing models within 1,000 guesses. Additionally, Pass2Edit's running time and password generation speed meets the requirements of a realistic attacker. The lower right figure shows Pass2Pass, Target2, and Pass2Edit's ability to crack password pairs across different cuisine similarity ranges. Now, let's investigate the passwords cracked by the 3 models. To demonstrate the ability to generate edited passwords, we removed the popular password dictionaries employed by Target2 and Pass2Edit. Our analysis results and cracking samples reveal that Pass2Edit can independently crack the highest proportion of edited passwords. Target2 has an extremely high proportion of cracked password pairs with an editing distance greater than 5, as it can transform passwords at the structural level. For more feature analysis and comparison, please see our paper. Finally, I'd like to share the takeaway and our future work. In practice, websites did not realize the data breach until months or even years after the initial data breach. A promising way is to detect the data leakage is to use honeywords. Honeywords are deco passwords stored together with each user's real password to impede the attacker from figuring out the real password. The key issue here is to generate honeywords that are indistinguishable from real passwords. As a leading password reuse-based model, our Pass2Edit has great potential to be employed to generate flat honeywords. Besides, large-scale password data breaches make it possible for attackers to obtain multiple passwords for the same user. Then the question is, how to use multiple existing passwords of the same user to further improve the guessing success rate? We leave this question as our future work. Thank you for your listening. If you have any questions, please feel free to ask me.